Problem number 4 says that Madeline wants to create a scale drawing of a room. So if she's making a scale drawing, that means she's going to make a small drawing to represent something that's much larger. So her small drawing is representing her larger room. And we know that the actual room is rectangular with a length of 24 feet and a width of 18 feet. There's some other information here that hopefully you've already read that I'm not going to waste time reading right now, but anytime you're making a scale drawing, you should actually draw a model to represent it. So let's do that now. This section over here on the right is what you'll see on the computer, and we'll get there later, so I'm going to cover it up for now with just another sheet of paper so I have more room. And we're going to make a drawing of what we already know. We already know that the room is rectangular with a length of 24 feet and a width of 18 feet. She's making a scale drawing of that room. So the drawing is going to also have to be rectangular, but we also know that the drawing itself is obviously going to be smaller than her actual room. It's going to be the same shape. Her actual room is a rectangle, right? So this over here would be her actual room, and this smaller drawing is the scale drawing. And then let's start labeling what we already know. Do we know the dimensions of the actual room? Yes, we do. The room is rectangular with a length of 24 feet and a width of 18 feet. This side appears to be shorter than that side, so let's make this 18 feet. And the longer side will therefore be 24 feet. And this again is the actual dimensions of her room. She's making a smaller scale drawing of that. Okay, so here we are. The scale drawing, this drawing, needs to fit on a piece of paper that's 8.5 inches by 7 inches. So this drawing is going to have to fit on a larger piece of paper. So what I'm currently doing now is outlining what we can assume would be the actual piece of paper itself, and usually pieces of paper are also rectangular. So this outline is the paper, and this smaller drawing is going to need to fit on that paper. They said the piece of paper is 8.5 inches by 7 inches. Which side looks longer than the other? Right, you should know that this side would be the 8.5 inches, this shorter side would be the 7 inches for the paper. So we're just labeling everything we know. Okay, the problem also says she also wants the drawing to be at least 4 inches wide and long, which means at least 4 inches wide and at least 4 inches long. So those are some pieces of information that are important to this problem. Anytime you're dealing with a scale drawing of something larger, we know that this figure is going to be the exact same shape as this larger room. It's just going to be smaller, right? It's still a rectangle, still have the same angles, just going to be a smaller representation of the larger image. Okay, so we have 24 feet represents the length. We can call this the length, and this would therefore be the width of 18 feet, and therefore this should represent the length of our drawing, and then width would be here. Width would be right there. Okay, so anytime you're dealing with scale drawings, you can set up proportions. If you have the length over the width, or you're figuring out the ratio of the length to the width, we know that the actual room dimensions, the length of it is 24 feet. I'm going to put that way over here. 24 is the length, and the width, what is the width? The width is 18 feet. And we know that scale drawings have to be proportional. So if this 24 over 18 is the actual room's dimensions, then the scale drawings dimensions will go here. The scale drawings dimensions will go here. So we're looking for a simplified or reduced fraction that will still be equivalent to 24 over 18. Ask yourself, what can I do to 24, what can I do to 18 to simplify and still get an equivalent equal fraction, but just with smaller numbers? You might say that we can divide the top and the bottom by 2, because these are both even numbers. 24 divided by 2 would give us 12, meaning 12 would be the length of this drawing. And you could divide by 2 and have the same scale factor on the bottom. 18 divided by 2 would be 9. And this is a true statement. Your drawing could be 12 inches long and 9 inches wide. But the question then becomes, is this drawing going to fit on this piece of paper? And you might be saying, well, no, actually. If it's 12 inches long, my paper's only 8.5 inches long. Right? So that's not going to fit. It's going to overlap. It's going to be too big. So we think of something else. We don't use 12 over 9. We don't simplify by dividing by 2. We can divide by something else. What can we divide by? On the top and the bottom, you might be thinking, let's try to divide by 3. Because 3 is a multiple, rather a factor. I take that back. It's a factor of 24, and it's also a factor of 18. 24 divided by 3, as we know, is 8, which means that the length will be 8th, and 18 divided by 3 is 6. Again, this is the ratio of length to width for our drawing. So this means that the length is 8 inches. Will that fit on our paper? Yes, it will. It'll be slightly smaller than 8.5. What about the width of 6 inches? Will the width of 6 inches fit on our paper? Yes, it will, because that's less than 7. So this works. A length of 8 inches and a width of 6 inches, that works. One other thing. We want to double check. It says she also wants the drawing, and again, these are the dimensions of the drawing, to be at least 4 inches wide and 4 inches long. Is this at least 4 inches wide? Yes, it is. Is this at least 4 inches long? Yes, it is. So that works. That's the first step to solving this problem. Okay, drawing a picture and then labeling your picture. So what's the width? The width up here is 6 inches. The width would therefore be 6 inches, and then the length would be 8 inches. And that fits on our paper, and it's equivalent to our actual room's dimensions. These are equivalent fractions. We'll get to the next part about taking this information and putting it onto the computer and drawing on the computer in the next video.